nature's ultimate powerhouse. Few natural phenomena inspire as much awe and fear as a tornado. These towering columns of swirling air can tear through towns in seconds, leaving behind trails of destruction that look almost surgical in their precision. But behind the chaos lies fascinating science, the raw mechanics of wind, pressure, and atmospheric instability, combining to create nature's most concentrated display of kinetic power. In this guide, we will unveil the full story of tornado power. What drives it? How scientists measure it? Why some tornadoes grow into monsters while others fade quickly? And what the latest research reveals about predicting, surviving, and even harnessing insights from these extraordinary storms. The science of tornado formation. Tornadoes do not simply appear out of thin air. They are the result of very specific conditions in the atmosphere. Most tornadoes form inside supercells, which are massive thunderstorms characterized by a rotating updraft known as a mesocyclone. When warm, moist air from the ground meets colder, drier air aloft, instability develops. Add wind shear, when winds at different altitudes blow at different speeds or directions, and the atmosphere begins to spin horizontally. Updrafts within a supercell can tilt this horizontal rotation into a vertical one, creating the conditions for a tornado. As air rushes upward, pressure at the center of the vortex drops dramatically, pulling in surrounding air, intensifying the rotation. This is why tornadoes can generate winds that exceed 300 miles per hour, making them one of the fastest and most disruptive wind phenomena on Earth. Measuring tornado strength. For decades, tornado strength was measured using the Fujita scale, developed in 1971. This scale estimated wind speeds based on observed damage. In 2007, the enhanced Fujita EF's scale replaced it, offering more precise correlations between damage indicators and wind speeds. On this scale, an EF0 tornado has winds of 65 to 85 miles per hour and might only damage shingles or small trees. By contrast, an EF5 tornado has winds exceeding 200 miles per hour and can obliterate entire neighborhoods, rip asphalt from roads, and hurl vehicles like toys. These wind speeds are so extreme that even reinforced concrete structures can fail. Understanding this scale helps put tornado power into perspective. Even a so-called weak tornado carries enough energy to flip cars, while the most violent tornadoes rival the destructive force of small nuclear devices in terms of localized energy release. The raw energy behind tornadoes. To truly grasp tornado power, consider the physics. Tornadoes concentrate enormous amounts of kinetic energy into relatively small areas. A large EF5 tornado may be less than a mile wide, but can pack wind energy equivalent to several gigawatts of power, comparable to the output of a large nuclear power plant. Unlike hurricanes, which spread their energy over hundreds of miles, tornadoes deliver concentrated bursts of destruction. The rotational speed, combined with the vacuum effect inside the funnel, creates both horizontal tearing forces and vertical suction that amplify their damage. Researchers estimate that the most violent tornadoes can release energy in the order of hundreds of terajoules. To put that into perspective, that is roughly the energy released by the detonation of the atomic bomb dropped on Hiroshima, condensed into a path only a few miles long. Tornado outbreaks and super tornadoes. While a single tornado can be catastrophic, outbreaks, where multiple tornadoes form from a single storm system, can devastate entire regions. Famous outbreaks include the 2011 super outbreak in the United States, which spawned over 360 tornadoes across 21 states in just 4 days, killing more than 300 people. Super tornadoes, like the 2013 Moore, Oklahoma EF5 tornado, demonstrate the upper limits of tornado power. This storm had a damage path 1.3 miles wide and nearly 17 miles long, destroying thousands of structures and myths. Events like these highlight the terrifying scale of tornado potential. The latest advances in tornado forecasting. Historically, predicting tornadoes has been one of meteorology's greatest challenges. Warning times used to be measured in minutes, leaving residents little chance to seek shelter. Today, thanks to Doppler radar, satellite technology, and AI-driven predictive models, Forecasters can often anticipate tornado-prone conditions hours before a storm forms. In 2025, machine learning models are revolutionizing tornado forecasting. By analyzing enormous datasets of past storms, these systems can identify subtle atmospheric signatures that precede tornado formation. This has improved lead times, with some warnings now issued 20 to 30 minutes before a tornado touches down. Research is also focused on no-casting, the ability to give ultra-localized warnings using real-time data feeds. Tornado safety and human survival. Despite advances, tornadoes remain lethal and safety awareness is critical. Experts stress the importance of having designated safe zones, basements, storm shelters, or interior rooms without windows. Mobile homes are particularly vulnerable, and evacuating them for sturdier shelter is essential. Modern technology is also giving people more tools. Smartphone apps can deliver real-time tornado alerts, while smart home devices can trigger alarms automatically. Communities in Tornado Alley are increasingly investing in community storm shelters. The hope is that improved forecasting, combined with better shelter infrastructure, will drastically reduce casualties in the years ahead. Tornadoes in a changing climate. One of the most pressing questions scientists are asking is how climate change is influencing tornado activity. While the total number of tornadoes each year has not shown a clear upward trend, patterns are shifting. Studies suggest that Tornado Alley is slowly moving eastward, with more outbreaks occurring in the southeastern United States, a region with higher population density and more vulnerable housing. Warmer, moister air provides more fuel for thunderstorms, and an increased instability may lead to more clusters of tornadoes in shorter time spans. Climate scientists are using AI-enhanced climate models to simulate future scenarios, trying to predict whether tornadoes will become stronger, more frequent, or more widespread as global temperatures rise. The global picture of tornadoes. Though most people associate tornadoes with the United States, they are a global phenomenon. Countries like Bangladesh, Canada, Argentina, and parts of Europe also experience devastating tornadoes. Bangladesh, in particular, has suffered some of the deadliest tornadoes in history due to high population density and limited shelter infrastructure. Global research collaborations are now sharing data across borders, making tornado science more robust. International efforts are helping improve global warning systems, ensuring that lessons learned in the U.S. benefit countries with fewer resources. Future research and tornado power studies. The latest frontier in tornado science is understanding their internal dynamics at resolutions never before possible. Mobile radar units, drones, and AI-enhanced modeling are providing glimpses into the chaotic flows inside tornadoes. Scientists are also experimenting with supercomputers to simulate tornadoes down to the meter scale, hoping to unlock secrets about why some storms spin up catastrophic tornadoes while others do not. There is even research into whether tornado energy signatures can be detected in advance through electromagnetic signals or seismic activity. If proven viable, this could open the door to entirely new types of warning systems. Respecting and learning from tornado power. Unveiling the true power of tornadoes is both humbling and inspiring. These storms remind us that despite technological progress, nature still wields forces beyond our full control. But every year we move closer to understanding their mysteries. From the chaotic mixing of air masses that give birth to the vortex, to the raw kinetic energy that rivals nuclear weapons, tornadoes embody the ultimate expression of atmospheric power. Thanks to modern science and artificial intelligence, we are learning not just how to survive them, but also how to predict and adapt to their evolving behavior in a changing climate. In the end, tornadoes teach us about respect. Respect for the power of the atmosphere, respect for the importance of preparation, and respect for the scientific quest to turn chaos into knowledge.